Nice. Monday night. Thanks God it's Monday, so we can do another coding challenge and try to crack some problem under 40 minutes, hopefully. Let me just check if everything is working. Seems like that. Right. This stream is for entertainment purposes only. And let's see if today we can anything but hard problem. Or I guess this generator just hates me. Right. Pick one and it's hard. No? Yes? No. Whew! Medium! Yeah! Finally. And in exam room, there are n seats in a single row. All right. Numbered, okay, 0 and -1. When a student enters the room, they must sit in the seat that maximizes the distance to the closest person, a COVID world, this kind of thing. If there are multiple such seats, they sit in the seat with the lowest number. Okay. Also, if no one is in the room, then the student sits at the seat number 0. All right, so the first person always sits at the seat number 0, I guess. Returning class. Exam room that exposes two functions. Sit, returning an int representing what seat the student sat in, and leave, P, representing that the student in seat number P now leaves the room. It's guaranteed that any calls to exam room have a student sitting in seat P. All right. Input, exam room, sit, 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 leave, sit. Output, obviously nothing has been done because we have constructed that class, and sit first to 0, then to 9 to maximize the distance, right? Oh, that's because we started with 0, right? And sits. That's what we initialized. Okay, yeah, that's good. So sit, 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 leave, sit. Output now 0, 9, then 4, then 2, because it can be either 2 or say 6, but we don't care. So in this case, we first put the lowest number, and then now 5. All right, so what do we do? I wonder if there is no such seat like at all. All right, obviously leave is O1 operation, right? We just say false. But what about sit? It sounds like all right, we need some fancy data structure here. I mean, the easiest way is to have leave in O1 and seat in linear time, right? You just go there and find two indexes where the distance is sort of maximum, right? Starting from 0. All right, so let's go with this one, like very trivial solution first, and then see if we can do it sublinear. Maybe we can use Q or something that tells me, okay, the next seat available is this one, then this one, then this one, and then this one, right? Mm-hmm. Because it sounds like, based on the rules, you see them, you see them always in the same places if you start filling this one, right? So obviously, although that may change, let's say you remove 0, right? Uh, and then, oh, you remove, let's say, okay, let's switch to the whiteboard, right? Just to see if the Q is feasible like at all. Or maybe something smarter we can do here. Maybe binary search, which, okay, let's see. So let's imagine this seed of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's imagine that initially we, okay, 0, then obviously 9 will be the max. Then we say what, 4, which is in the middle, then either 2 or what? So this is one distance, this is one distance, this is, or these two, right? Doesn't really matter. But we will select these two. Then we sit someone here, right? And then next time, let's say someone here, right? So what I'm trying to understand is that, so yeah, every time we will sit in this guy, and only that, this guy. So there is no way I can remove something. So it shifts, let's say, to 3 first, then to 4, or something like that. So if this is the case, then really what we need to do is, once we initialize the number of seats, we know the order at which we seat them, maybe except 0 place or something. And we say that every time someone leaves, we put this seat to the queue, right? Somebody returns, we pull this seat back as the first choice because it increases the chances. Because whatever, it feels like no matter what I return from the seats that I already filled, they will be next in the queue to file. Maybe unless let's say the extreme case, right? Everything is occupied, right? So I return, say 8. So I put 8 back to the queue. And then next time somebody leaves, it sits 3, right? So I put 3 back to the queue. But obviously, maybe I can have a pair where first one will be the priority of the seating, and the second one will be the distance. So can I compute? So basically to have a queue, so the priority will be either distance or the number, right? Whatever is bigger. So every time I remove something, right, I can see the closest neighbors to it and sort of, what is the linear time in between these things? Mm-hmm. Yeah, I don't know. Yeah, let me first go with trivial solution, and obviously there will be a better one. I guess you can do something with Q, very smart here. But so far, let's just do, let's return back to the main screen. Say, again, we don't care, to be frank about. So we have this, let's say private, say int, or let's just even vector of int p, or sorry, seats, right? And all we do is say seats, and that's how we initialize it. All right, should be like that. So if we leave, and it's not int, it's bool actually. All right, so let's check cpp init vector of bool. True, false. Just comma and then false. All right. So if it's correct, it should be like this. False. Then sits p equal false, and sit. We can also say int. We can. So we need to check if it's empty or not. If it's not, then 0. So yeah, we're about like 10-20 minutes into this problem, so it's okay. So all we do, basically say min dist int min dist equal to, let's say, max int, right? So in a way, so what do we say? Yeah, let's do this. Bool. So can we do this in linear time? So that's the question. So we can check the I. So if I go like this, right? So let's say this is occupied. So I say, okay, no place. Let's say this is 1 and 2. They're empty. So I start to count. Okay, this is distance 1. This is distance 2. It's a max distance, not mean distance. Let's say -1. So if it's negative, then we know if max distance, or actually, yeah, it doesn't matter. We just say int seat equals 0, right, and return seat. So then it's 2. Then this one is what is 3, right? So what do we don't know is what's the right side for this thing. And to find the right side, at the same time we find the left side, we can do, first we traverse this way and find for every element the distance from the left, and then we do the same thing and find for every element the distance from the right. And then what do we need to do is just to see which one for every element will be what? The max out of the mean between two, right? Max of mean, max mean, max mean. Right, so okay, so the trivial one, and it's stupid, I know, but the trivial one, especially in terms of memory, will be this, right? We start bool integer, say max left distance, or yeah, max left, and its size of what? Of, we can say seats size. So what do we do? And let's say it's 0, right? So we don't need this. Then, so all we do, we say that max left, and then we start with 1, because obviously for the 0 element, there's nothing on the left. There's like infinity, whatever. It's 0. We don't need to. Yeah, we can say that max left. So for the 0 element, max left, so will be the maximum number, which is just n again. So we can say that 0 element is the max. So no one on the left for 0 seed. Same for the right side, right? So then we start with 1, obviously, if at all, and then say, okay, max left equal to what? Equal to we say last int last occupied, right? And then, yeah, so let's see, last occupied. It's occupied. We can init it to 0. So or let's say -1. So every time we check last occupied less than 0, then we say what? Seat size, basically. Then it's also maximum on the left side. We don't really care, right? So there is no limit from the left. That's all we want to say. Otherwise, it's I minus last occupied. Now, after that, we should say if seats I, so if it's occupied, then we say last occupied equal to I, right? That's it. So now we do the same for max right. We can basically do last in one cycle. We can say left occupied here, right? Left occupied I max left I last occupied, because this is symmetrical, so there is no need to run 2 cycles. So we can do same thing and say max right, and then we say that seat size 1, so the rightmost minus 1 equal to the, oops, they just basically copy this thing, right? 0, seat size, and this is seat size minus 1. So again, no one on the right for n minus 1 seat. Int left occupied right occupied finally, after this cycle, if left occupied and right occupied. So if both are minus ones, should I say that? So what would be if it's 5? I don't know. All right, I guess to false in this case, but whatever. Let's just say if left occupied is less than 0, which means no one there, and right occupied is less than 0, which means no one there, return 0, right? And then we have else, then we do something there. We will get to this later. So here is straightforward. So we do this for max left, and then for max right, it's same algorithm, just in the reverse order. So we start with -1. So we say seed size -1 because this is the last element, and we don't care about last element. We know that this is 0, -1 minus I. All right. Equal to, then we say right occupied less than 0, then seed size, otherwise, then it will be right occupied minus what? Minus this thing. Right. It doesn't look good though. So let's see if we can simplify this stuff. Something like this at least. So the idea is if the element except the last one. That's what it is. It sits 0, then 0, otherwise -1. Similarly here, sits size, size -1, then seed size -1, otherwise -1. Right. There we go. So we definitely know that if both are negative, so nothing is occupied, we just return 0 position. That's where we sit. Now, because the goal, if there are multiple equal seats in terms of the distance, we return the lowest index first. So that's what we do. We run. Okay, so what do we do here? We measure distance from the left first, and then to the right. So simultaneously, we file these distances for all of the elements, right? So for the left, we go from the left and say, okay, starting not from 0, but from 1 position. And say left occupied is negative, then seat size, so we don't care, right? If not, then it's our current position minus last occupied position. Right. Then we do for the max right, similar thing. We go through almost the one element prior to the last one first and see if on the right, meaning the last seat, is occupied. If not, then okay, we say seat side. So we don't care. We kind of release the constraint on the right side. So basically, there is no distance at all. Then we move. If there is someone, then there will be the difference. And the difference is, we start with this one, right? If right occupied is seat size -1, then it cancels out each other, and the distance is I. So in this case, if I is 1 and last occupied is 0, the distance is 1, basically. In this case, it should be 1, 2. And it will be 1 because I is 1 in this case, yes. All right, so then we need to do similar stuff here, but for this guy. All right. Ta-da. And it's right occupied. All right, so we done this, we check this condition. And now we do the simple cycle again. So we basically run this thing, but now from 0, from first to last. And all we check is the following rule. So we have this int max dist, which we can say 0, nobody cares, and int seat that we should return, that we can say 0, whatever. So all we do, we check this. So if for every given element, right, max dist is less, only if it's less, right, then max dist, then mean of what? Of max left, then max right, right? If so, we say that max dist equals to this thing, and seat is equals I. And after this cycle, we can just actually move this thing here. We don't need it. After the cycle, we return seat. Okay, that's it. It's all one. It's linear. Oh, yeah. Can be sublinear. Linear with Q. So it still feels that there's something more smart that we can do than every time calculate like what's the next element to assign. It really feels like it's a queue kind of data structure that they're looking for, right? Maybe you don't need leave in O1 like in our case, right? In our case, it's O1. It's just constant simple operation. Maybe you can use n log n to leave, basically to remove element from the queue, and then n log n to retrieve the next element from the queue. And if the queue is empty, then you just push the 0 element there, right? Or it might be the queue of available seats. So all of the seats are available. So by default, 0 element will be preferred one because for everyone distance is something. But every time you insert, then it somehow should automatically recompute the distances for every, all right, for every node. Yeah, so it's something tricky. This one is ON or 1. So let's see if at least it runs for some tests here. So we're about like 30 minutes. So I guess it will be our final solution. But still, I feel like the Q is the case. Should it be? I guess it should be this way, right then. And technically, we want to say technically to be this one. I have to be completely honest with you. We don't want to sits. Oh man, so much sits. It would be easier just to have n somewhere here instead of n size. Yeah, let's by the way do this. Int n, so we know it, right? So let's just say n is n and seats are these one. So then every time we do this, we can just say n, right? So do we really need seat here? Oops, I don't think we need it. It's not needed here. Seat size to this thing. Right. Boom, boom, boom. And I think it should be something like this, right? So the location of this element. So we don't screw with signs. All right. So then it's n, same thing. So let's do this. Here is the same thing. I will save a little bit on space here. Looks more denser though, but whatever. And then again we say n. Yeah, it should be left. I minus left, right occupied minus current element, if it's not 0. Run code. What the hell? Of course. Wrong answer. Interesting. It always returns 0. How weird. Oh, I think what we're missing is this, right? So we need, before we return anything, we should say that sits, we do not assign, right? 0, true. And same here, sits, true. Nope. Interesting. Why not? So it always returns 0. The reason it returns 0 is nothing is occupied. So if nothing is occupied, then we say, okay, see, it's 0, right? So let's just check here. Right, we have right enough time to occupied, false, 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 and false. All right, so let's also add a little bit of things to ease the debugging. Seat 0, occupied 0. Oh, that's why left occupied or right occupied is, yeah, nothing is occupied, right? Nothing should be occupied. So nothing is occupied. That's what we see. This is weird. Obviously it's 0. Okay. All right. So then it's 1. It still returns 0. So if left occupied is less than 0, but right occupied is not, so it should be false, right? So that's why we see it only once. So we see it only once. We don't see it after all. So the reason is the max distance then is weird. Right. So don't really care about seats anymore. But let's check what's the max distance, right? See out. So seat I distance equal to this thing, right? Equal to this thing, and return, we say so why on earth 0, 1 ah I know one because for 0, 1 it's the distance is max, so technically what's missing here I already know is this thing, right? The condition that if sits I continue. So if seat's already occupied, we don't care about the distance of it. That's what's missing, right? Yes, seems like we've done it. Submit, and it doesn't pass the time limit, I guess, because it should be log n. Or maybe, yeah, time limit exceeded, exactly. Because you should use the queue, but that's okay, we run out of time, so we just failed medium task, it also happens. But at least we solved 112 out of 128, nice. Not actually, so let's switch to the whiteboard. Hey, at least we did linear, right? We didn't do quadratic or any other crazy stuff. You just use the queue here, that's my feeling. Like super strong feeling you're using queue and then it will be super easy to solve. I just don't know how do you recompute them. I guess because the rules basically always tells you first this, then 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 this. So it's like binary tree all the time, right? So like you search, you basically have this array and you use binary tree to search available place in it, right? You just initially check, okay, if it's empty, then 0. Then we start with this. Okay, so what's next? Then we go to the rightmost. Okay, it's occupied. If this one, then central one. The central, so this and this occupied. So then this one, right? So we don't need to go through all elements to compute distances because you already know that if these two, if central occupied and the leftmost occupied, then it should be between them because the rightmost was also already occupied. Yeah, maybe something like binary search here could also work, or just the tree with some distances, and then you just reinsert it back. Whatever. So it's 0, and we solved what 112. Let me just 112 out of 128. No, I guess just this is fine. So thanks everyone. See you tomorrow, hopefully.